Isn't it great of Cisco to provide us with a nice check when we are examining this checklist. It's very, very easy for us to go ahead and follow this checklist to ensure that the network we are working with is within this network health checklist. And again, the built-in tools are the way we can easily do this. I mean, let's take a look, before I forget, quite honestly, let's take a look at that network information we obtained from running that show tech support command. Let's go ahead and bring that up before we forget. Yeah, look at this. It ran that important show version command for us and gave us the output. It ran that important show running configuration. It ran show stacks to see the processes that are running on the device. It ran a show interfaces. It just ran a large list of very valuable show commands that report on the intimate details of the health of this device. It's no surprise this is the kind of information we're getting from this command, because after all, this is a file that we are to send to the Technical Assistance Center in order to get help with our device. Obviously, look at the show interface command. It's going to have lots of different information about packets coming in and packets leaving the interface. And a lot of this information is the type data that we need in order to make sure that our particular system is within the constraints, or within the guidelines, I should say, of this network health checklist. Let's take a look at these line by line and make sure we understand them. And by the way, some of these I would say would be worth memorizing. I'll go ahead and highlight what I would have memorized if I were you. Ethernet segments should not feature a sustained utilization of 40% or higher. I'd have that number memorized. So when we are looking at our local area network links, when we're examining our LAN links, those LAN links should not be greater than sustained utilization of 40%. Notice that's most of the capacity being available, or a good chunk of it. About 60% of the bandwidth should be unused. Now you might say, wait a minute here, that's ridiculous. Please keep in mind the use of this word here, sustained. So, if you look at a graph of the utilization, for instance, so when you look at a graph of your utilization, it's not like you're never going over that 40% number. Sure, you're going to go over that 40% number. That's expected. But what we're talking about is, that it's not a sustained utilization percent that's over the 40. So, here's time, and here's the utilization percentage, and, we're running like this kind of thing. That's normal, where our 40% might be right here. Notice we're not running, we could go over the 40%, of course we could, but we're not running at a sustained 40%. So let me grab a different color here. So we don't see a utilization graph that looks like this, where we are consistently sustained at 40% or above. Okay? So that's a very, very important word here, that word sustained, as we consider the LAN utilization. LANs, by their very nature, offer very, very high bandwidth, so we shouldn't be at that sustained 40%. Now, a WAN, a wide area network link, okay, a WAN link, notice their sustained utilization shouldn't be higher than 70%. Notice that's a bigger percentage, and that's because WAN links, by their very nature, are lower in available bandwidth, and they also tend to be key aggregation points in the environment, right? Like some LAN switches don't get used all that much, but key WAN links get used by typically everybody. I mean, even your employees that are mainly just accessing local resources, they're going to be needing to go to the internet periodically. Maybe even it's during their break time to check their Twitter page, right? Oh, got a tweet about what I'm doing this hour. And yeah, those kind of access means that the WAN link that leads to the internet connection, for example, yeah, it's getting more use consistently by everybody in the network. So the lower bandwidth, more utilization of the WAN tells us that we should typically be running about 70% there or higher. Or we shouldn't be, excuse me. So 70% is that higher number. By the way, when it comes to the LAN, we should be using layer 2 switches. And we'll elaborate later on in the course why layer 2 switches are the key. What we don't want is we do not want hub-based networks. As we'll remind you later on, our hub-based networks get us into a lot of trouble because they have these big shared collision domains. And these collision domains make for inefficient communications. Memorization here, all three of these actually, I'm going to say, yeah, all three of these we would definitely want to have memorized for CCDA certification. Response times on the network. If you do a very crude little ping, the packet internet groper, you should see response times generally less than 100 milliseconds. Certain forms of traffic, you're going to have to guarantee these kind of numbers for. A great example would be VoIP. For voice over IP, you have to guarantee it that there is low latency. For other forms of traffic like, web traffic, HTML traffic, we don't have to be as concerned about that 100 millisecond number, but for, other forms we do. Remember, a lot of these network health checklist statements are generalizations. And in fact, that one even comes right out and says, yeah, look, generally, we want to be in that 100 millisecond area. LAN response times, by the way, when you're talking about one station talking directly to another station within the LAN, notice how those come down to about 2 milliseconds. Yeah. When we're not talking about going through a router, going through a WAN link, yeah, LAN response times should be very, very low. It should be lightning fast to communicate with someone, especially within your own virtual local area network, or VLAN. When you are looking at your segments, you shouldn't have cyclical redundancy check errors. There shouldn't be errors with packets in your network. There should only be about 1 per million bytes. So we have very few errors. And the reason why you have very few errors is you're not having collisions because you're in a purely switched environment. By eliminating the hubs, you should eliminate all your collisions, and therefore you shouldn't be dealing with cyclical redundancy check failures. Also, for your network health checklist, we shouldn't have segments, and I would memorize this one. This would be another one that I would memorize. We shouldn't have segments be more than 20% multicast or broadcast traffic. We definitely want to be careful with the amount of broadcast and multicast. That's real intensive for our workstations. That adds a lot of overhead to their lives, the multicast and broadcast traffic. So we do want to make sure we keep that down around the 20% number. We should have less than 0.1% of collisions. That's right. So 0.1% collisions or less. There really should be no collisions in your environment if you have set it up properly. How about that CPU utilization? Well, we saw how easy the show processes CPU would give us CPU info. Over 5-minute intervals, we shouldn't be exceeding 75%. The number of output queue drops should not exceed 100 in an hour. Input queue drops 50 in an hour. Buffer misses shouldn't exceed 25 in an hour. And finally, the number of ignored packets should not exceed 10 in an hour. Where do you find these numbers? Well, sure enough, these numbers are all reported to you in that show interfaces output that we talked about earlier and that we know is part of our show tech support output, of course. So we are talking about, we get into the details here and we might lose sense a little bit of what we're even talking about. So let's kind of back up and just kind of review a little bit where we've been up to this point, okay? Where have we been up to this point? And what we're talking about in this lesson, okay, that's taking, a good amount of time, but the beauty is of the way we set up this course for you here at INE is we are going to take our time. We're going to make sure we really understand stuff. Okay, we're not here to learn a bunch of techno babble so we can impress people. We're here to really learn this stuff. And we're taking our time as we go through this PPDIOO network life cycle that Cisco educates us about. And we talked about the prepare phase. We talked about now the plan phase. With the plan phase, we've seen things like the network health checklist and the auditing tools that we can utilize in order to carry out that phase. Now it's time for us to elaborate on the design phase of this life cycle. Remember, I'll talk to you about the implement, operate, and optimize phases, but those aren't the focus of this course. We're focusing on the prepare, the plan, and the design phases because this is a course in, surprise, surprise, network design. All right. Next up, we discuss a bit more details about the design phase. Yeah, we've finally talked in great detail about preparing. We've talked in great detail about planning. And now we're going to get into the stuff that makes up the design phase. In the design phase, we are going to finalize our diagrams, our equipment lists, and we're going to finalize the overall project plan. Okay? So we've finalizing here the diagrams, what equipment we're going to use, and the project plan that details how all this stuff is going to come together to form this intelligent information network, or at least give us the first phase of the intelligent information network. Now, we also may engage in the creation of pilots and or prototypes. And one of the many things we're responsible for here as a CCDA candidate is we need to know the subtle differences between pilots and prototypes. A lot of people would just consider them the same thing, but I said subtle differences. Yeah, there's actually some pretty major differences between a pilot and a prototype, and we'll take a look at that. And then the culmination of the design phase work is for us to create a design document. Wow, the design document. This is critical. And this is documentation, a key component of documentation that describes exactly how this network is to be implemented as part of the implementation phase. So, in our design phase, we finalize our diagrams and our equipment lists. We may be engaging in pilots and prototypes, but one thing we always do is we formalize the design document that will guide our implementation. Now, Cisco wants you to be aware of two overall approaches that can be used for finalizing the design phase and finalizing the design document. You might use a top-down approach. You might use a top-down approach. This is the most popular with true CCDAs. Yeah, when you're a true bona fide CCDA, you have your certification, you're working in the design field, you're going to preach to everyone to do the top-down approach. Notice you're starting with the applications at the top of these layers, and you're working your way down from the applications through the services all the way to the network infrastructure layer. Why is this approach so often preached by CCDAs? Because this really allows you to confirm that you are accurately incorporating those business drivers that we're striving to address with the network. You're making sure you're not building a network for the sake of building new technologies. You make sure you're building the network to address the business drivers, the organizational goals that really dictate what we do. You might think, well, why do we have to preach this? Why do we have to beg people to follow this? If it's so great and it addresses the business needs, why isn't it just something we always do? And the reason why we don't do it is it takes a lot of hard work for the designers and it's time consuming. To follow proper protocol and models is a lot of work. But that work, of course, pays for itself. What would be the complete reverse approach of this? It would be going from the bottom up. It would be going from the network infrastructure and moving your way up. Typically, engineers do this purely based on previous experience from other design engagements. They're like, oh yeah, get adaptive security appliances, plug them in over there, get an intrusion prevention system, plug it in over there, get a bunch of multi-layer switches from Cisco, plug them in there, and finally get a 7600 router and plug it in over there. They're all set, you're good to go. It allows for quick solutions based upon previous experiences, and this is the way in which we can have inappropriate designs as the end result. Oftentimes, the bottom-up approach will be implemented quickly, it will work, but it will miss some of the key organizational goals that we would have wanted to implement. And by the way, it can be for a dramatic higher cost than is necessary. A lot of the times, this is when we have overkill, and we have devices that are only being utilized for 10% of the things in which those devices can do. So it's not like we're always, undershooting what the company could do from a technology standpoint. Oftentimes, we're completely overshooting what the company needed in order to achieve its organizational goals. Now, something that we know that we might engage in this design phase of PPDIOO is pilots and or prototypes. I told you that we really need to be responsible for the differences between a pilot and a prototype, and let's cover that right now. A prototype is a subset of the full network or Sometimes it's a representation of the full network. So it's a smaller scale version of the full network. But here's the thing, it's done in isolation. Okay, so it is built in complete and total isolation. And we do the prototype for experimenting and making sure that we understand the technologies, the company understands the technologies, they see how they're going to work, and they get a full proof of concept that it will work. Notice a pilot is when we do a chunk of the network or even a subset or a representation of the full network, but the key is it's a live location and it is part of the actual production network. So a prototype is done in isolation. A pilot is done as part of the actual network. What is the beauty of the pilot? Well, because the pilot is is a live location in the actual network, you're going to potentially come across real network issues. I mean, if there are problems that these technologies are going to have existing in this network, yeah, those problems are going to become pretty darn apparent. Those problems are going to become pretty apparent because this small pilot portion of the network is existing in the actual network. So, pretty cool, pretty powerful, the ability to have this prototype of the network and or a pilot of the network. All right. Sorry for the pause there. I just had some background disturbance that I had to work through, but we got that solved. So, pilots and prototypes. Now we understand the difference between these, and we won't just use those terms interchangeably anymore. How about a little more information about that important piece of documentation that we get out of this design phase? We said one of the things we're always going to get out of the design phase is a design document. Here's some more information about that design document, specifically what you'll want it to include. Obviously, there'll be some form of introduction. Okay? Who we are, why the design document exists, who authored it, what are the key contact information for the design document, etc. And then the design requirements. Wow, this is so important. We have to talk about those organizational goals and the goals of the network that we are trying to implement. So, an intro and a review of the requirements, critical. Then we can go ahead and include the full documentation that we now have just beautifully, beautifully rendered. And this portion can cover completely the existing network infrastructure. So we're going to have any existing network infrastructure that might exist. We're going to have that beautifully diagrammed out and present in the design document. Then we have the design itself. Okay, details of the design itself. We'll have the results of prototypes and pilots in our proof of concept section. And then, very important, the implementation plan. So we'll have the implementation plan, and we'll be talking about that more in a moment. This section of the documentation, obviously, I want to talk about more in the next phase, which is the implementation phase. And then you may have a bunch of appendixes in this design document. The appendixes are just things that you want the decision makers to have awareness of. You want them to have information about these facts. But these appendixes don't neatly line up with any of these other sections that we've detailed for you. So, we have discussed preparing. We've discussed planning. Now we've given more details about design and the ultimate effect of the design phase, the design document. Now we will go ahead and briefly talk about implementation, operation, and optimization, although we know these aren't the main focuses of CCDA. The implementation plan has you following two things very closely. Obviously, the overall project plan, and obviously, we're going to follow very, very closely the design document. That's right. There's going to be the full information we need about the implementation, and that's going to be a huge part of the design document. By the way, in the design document, it's going to detail setting up the network in steps, and the design steps of the network should each include a description of what's going to happen in this implementation step, what guidelines there are for the implementation, how long it should take that particular step in the implementation. If something were to go wrong, what are the exact steps to roll back this phase of the implementation, and any particular reference information which might help the implementer of the technology. And many times it's not the same individuals that are responsible for both the design and the implementation. So you want to help out the implementer as much as possible by giving them any necessary reference information. Next, we have the operate phase of the network's life cycle, and now everything is properly implemented per the project plan and per our design document, and now it's time to happily operate the network. Things that we're going to be doing in the operate phase are things like our recurring network management and our recurring network monitoring. Occasionally, we got to go in and do recurring routine maintenance. Periodically, we got to go in and do our upgrades. We want to make sure the network is performing properly, so we do our recurring performance management, and occasionally things are going to go wrong. We need to detect those faults, and we need to correct those faults. And remember, one of the key guidelines we're going to do with this is we're going to use as much as possible the concept of being proactive. Very, very important that we be as proactive as possible when it comes to detecting faults and correcting them. A great example I gave earlier in the course was seeing that a WAN link is starting to have that sustained 70% or greater utilization. If you can proactively catch that before it becomes a major problem on the network, you're really, really doing a great job when you're operating your network. Finally, the last phase of our PPDIOO life cycle of the network is to optimize. Again, we want to be proactive. Through our consistent monitoring of the network, we should see when things really need to be optimized. And of course, this may lead us right back to the first phase of prepare. And this PPDIOO life cycle may start all over again. Maybe for just an area of the network, or maybe for a new segment of the network, or whatever the case may be. But this definitely can start all over again after we are through optimization. We may decide, yeah, we need a redesign, or one area of the network needs a redesign, and we start the process all over again for that particular area. So, very, very cool, isn't it? Cisco providing us this guidance on the major life events of a network and giving us guidance on how we should operate, how we should function, I should say, not to get us confused with the operate phase, how we should function as network professionals during each phase of the network. Our focus was obviously on the prepare, plan, and design phases here in our discussion, since this is a course in design. Before we wrap up this second and final lesson of our first module of CCDA, let's take a look at some exam review. One of the things I told you you would be responsible for sure is you got to be able to name these PPDIOO phases, and you'd want to be able to place them in the correct order. So, this is an area when it comes to memorizing things like this where flashcards can really come in handy, right? Flashcards, either electronic or paper-based, can really help us. We know it's prepare, plan, design, implement, operate, and optimize. And we know our focus in this course is going to be on preparing, planning, and designing, but we'll have awareness of all cycles of this particular life cycle by the time we're done with this course. What is a disadvantage of the top-down network design approach? Well, this is actually a pretty good question because we know it's primarily just advantages. We love the top-down design approach. Remember, with the top-down approach, we are starting with the applications, and we're going to design down to services, and then we're going to start thinking, after we talk about the services, then we'll start thinking about the actual network infrastructure. So when we design this way, this top-down approach, we are typically really hitting the business goals of the organization as implemented through the applications. This top-down approach, it is difficult and time-consuming compared to the bottom-up approach of network design. But why we would want to target this top-down approach is the fact that it is so typically in great alignment with the organizational goals. Top-down approach is something that typically hits the mark, and that's why we want to consider it as our main focus. Well, folks, I hope you've enjoyed this exploration of the PPDIOO life cycle from Cisco Systems. I hope you are well on your way to mastering this material in this lesson. And next up, what we'll be doing is turning our attention to the second module of the course, and we're going to talk about how we can use modular network designs in order to ensure we are designing the most effective and efficient networks possible.